It's Noman here, and this is me building in public. So the idea for me was to kind of build a music player, right? And what I decided to do was to kind of use the Raspberry Pi over here. There's the Raspberry Pi to do so. But I knew the Raspberry Pi had some problems. So the board I got had to use micro USB and not USB-C. It had limited storage, like 2 MB. Apart from that, I kind of did like a proof of concept. So that was like the idea. Hey, let's do proof of concept to see if this works. So I wrote a script up in MicroPython. I ordered the Pi. I put everything together, and yeah, I ran into some problems. So the pros of the Pico, right? So the new 2350 Pico is has more RAM, has a faster CPU. There are many connections for external controllers, and it's really cheap. It's like $12 to get started. But it's $12 to get started just for the board, right? I spend another $12 getting the breadboard, another $5 getting cables, another $10 for another cable. And when I say cables, I was referring to like these nice jumper cables over here. So that was there, right? And then what I did was I ordered this small board over here. I forget what it's called. I think it's the PCM 5101. Yes, so it's basically a digital to audio converter. So it converts digital audio signals uh, to analog. This is basically a DAC, and you can connect like headphones to it and everything. So I got everything going, and I faced a lot of problems to get that going. Firstly, is that I got one breadboard with the kit I bought. So it didn't have a lot of space, had missing cables, and shipping takes time. Like everything takes 2 days to ship, which is quite long. Like back home in Dubai, I get it in 4 hours. So like it's just a matter of waiting. Anyway, so this is like stage one of me building in public, right? Stage two, though, is where it gets interesting because I realized that the Pi had a lot more problems. And this is after I was coding things and researching, right? So apart from the USB-C and limited storage, it can only play WAV audio files, right? And the reason for that is WAV is an uncompressed format. So most MP3 and MP4 um, files are compressed, and there are algorithms that run on your computer to like decode them and uncompress them. So you need more processing power. And I was just like, okay, cool. Let me try this with a WAV file, right? And I proceeded. Then I faced some more problems. So now at this point, I had all my components, right? But I could not get the music output to work. So I wrote the script for it in a tool called Thonny in MicroPython to get started. And I realized I have no tools to test. So I don't have like an amp meter or oscillator, the thing that shows waves in the monitor, right? And after doing some research, I realized that I might need to write the firmware in C or C++ for efficient decoding or encoding for the MP3 and MP4 formats, right? And the current code that's written in Python just has too much overhead and just can't do a lot. So I would have to write it in C or C++. Next thing I realized is each compressed song is like 4 to 8 MB, right? And the Python has 512K of RAM. So I was like, okay, cool. Let me get started on this. Okay, what can I do to get around that? So I went through doing some research. I went on Reddit, went through some manuals, only to realize that the Pi supports something called PSRAM, and there's a QMI interface somewhere on the diagram that allows you to connect to it, right? But then I came across more problems, and I will tell you that. Okay, so this video is in like two halves, but I'm gonna like merge them together. All right. So lastly, I figured out that you can add RAM to this using something called PSRAM, right? So I gotta research how to do this. So a couple of next steps for me is to get a new DAC, maybe pivot to something simpler because my old DAC didn't work, right? Because I couldn't get music output to work. And continue working on this as a less important project, maybe because again, the components take time, and I now have sort of like a rough product architecture of how to do things. So what I did was I figured out what the limitations of the Pi are, right? And what I would need to do as next steps to kind of make this project happen. But I think making a music player for like a summer project is not the best idea, right? And I'll tell you why. Uh, you need to have a battery attached to it. I haven't figured that bit out, by the way. I have to write C, C++. From where I need to get started on that, I don't know how long it will take. I don't know how hard it will be. But yeah, these are all issues that are there. Next is I need to kind of figure out how to connect like a eMMC NAND to it because if you want to put like a few thousand songs on this, right? Ideally, or a few hundred songs, I'm gonna fit on a 2 meg flash. And since the MP3 and MP4 files are gonna be compressed, right? I need to find a way to save processing power because the chip on this is not very powerful, right? It's like a 150 megahertz or 120 megahertz dual core ARM processor. It's a tiny ARM core, right? So I'm gonna need one day to get the new music controller, which I've kind of designed here in Figma. I need to figure out how to connect a NAND flash. So my idea right now is um, basically the user would connect to the NAND flash whenever they connect to the music device. So you would click to the you would connect through the USB-C. There would be a USB controller that would connect to the NAND flash, and then the Pico would play the music off the NAND flash, right? And then it would send the output to music controls depending on your physical control input. So these would be the buttons on the music player because this is going to be like a button-based music player. It's not a touchscreen. I really wanted to do a touchscreen, but that seemed a bit difficult. And that's mainly because I was looking at the iPod Nano, right? And I was like, hey, can I make this product? But yeah, this seems a little bit out of scope. So I was like, okay, cool. I'm just gonna build a music player using Raspberry Pi, using physical controls, music output, and I think a lot of this is a lot of scope. So my next steps are sort of going to be to get the new deck. I've already initiated the return process on Amazon to get the new deck. I don't know what's wrong with it, but I'm just going to send this one back and get new one just for testing. If that doesn't work, I might ask someone for help. If you know some electrical engineers that know what they're doing, uh, send them my way. I'm a computer science guy. I know how to code. I suck at hardware, but I'm learning. Just as an FYI, I spent like 2 years as a product manager in the hardware space, so it was quite challenging. Anyway, back to the project. So I need to get a NAND flash, USB controller, USB-C. I might need to change the board out to do something else. And I've been looking at the ESP32. Maybe the ESP32 might be a good alternative, right? It is possible to do this, but it's like a hacky solution where sort of I'm just gonna draw a line here, so you guys know what I'm talking about. Basically, there would be two distinct systems running in the music player. One would be the storage, USB controller, USB-C, the everything, and then everything else would be on the Pi, right? Which is the firmware, battery, physical controls, music output. That would be handled by the Pi, and hopefully that takes care of the issue I will have with compression and decompression. Sorry, uncompressing audio files. I might need to have another chip on board, which would mean having a custom board made or finding a custom board. So that's there as well. And lastly, if you guys know anyone who can like give me or find me like NAND development boards with USB controllers, please let me know. Thank you.